Hello guys. So let us discuss this problem today, which is called shortest path in binary matrix. So given a grid of binary matrix n into n, we need to find the shortest path between the top left cell and to the bottom right cell. The only condition should be the visited cell should have to be 0, and we can move both up, down, all the possible directions. Means there could be 8 direction possible. We can move from one cell to other. So we need to find the way. What is the shortest path which we can traverse from this top left to the bottom right. You can see this in this example. We can just traverse this, so the shortest path will be 1 plus 1. So when we start from this cell, this will be itself calculated as 1, and the next will be 1, so it will be 2. Similarly, if you see this example here, you can see we'll just start from here and we can traverse this 0 0 0 0. So there will be total 5 cells, but we can skip this cell because in the problem it states that we can move 8 directionally. So directly we'll skip this and we'll go diagonally. Then we can reach this cell from this using 4 cell 1 2 3 4. So the shortest path should be 4, not 5. And if there is no possible way to go to this cell which is 0 or 1, then we'll just return -1. So the implementation basically will use BFS, breadth first search methodology, to traverse it. We'll start from the top left, and we know, like, we in breadth first search we'll use a queue to traverse it, and we'll keep appending the queue, and we know the queue will act as a first come first serve basis. So here we can see we have taken a queue, and we will take a queue of pair and pair pair of pair and int. So the pair should be, will store the pair as a index of the starting cell, which is 0 and 0, and the 1 should be the length, number of path or length to reach that. So when we start from the cell, the initial length will be 1 itself, so we'll push that index and the length. And the other case will check if the starting cell itself is not 0, means if it's 1, then we'll directly return -1, because if the starting itself is 1, then we can't traverse, because every cell should be 0 in the path, so we'll return -1. And also, if we'll get only one cell, 1 into 1 means the cell is 0, and it's the bottom and the top left, both cell is same in this case, so we'll return 1. So after handling the base cases, we can see we can directly use a boolean visited array. So the boolean visited array, you will just store, means, let me draw. So for example, we have a 2 into 2 cell, 2 into 2 cell. Here we'll just move this. So when we traverse any cell, we'll just mark is true. If we are not did not traverse, it will be false. When we traverse it, we'll modify the false to true. In that way, we'll keep knowing that which cell is being traversed. So this will act as a visited boolean array. This will be visited boolean array, and the queue, will be appending the indexes. We'll be appending the indexes here, and we'll keep popping it from the front. When it's popping, then this will become, and will increment the length. So we can see when we add the first index and its length, and we initialize the visited array all cell as false, then we just, as we starting from the first top left and top cell, we'll just make it true, and we'll keep iterating when the queue is not empty. How we'll do that? We'll have the pair of queue. So pair of queue. So the first pair is having the indexes, and the pair of second is having the length. Firstly, we have added length as 1, and the first and the second is the indexes of the current index. So this will be the x and y will be the current index, and as we know in the we can traverse it eight directionally. So we'll have a vector of pair where we'll have all those eight directional way we can start from a cell. The main issue is like we cannot go back here. So if we go back, this will be out of bound. So we need to handle those cases so that we don't come out of bound of the cell. So we'll just use this for loop to traverse eight direction, and we'll check if this is new x, will calculate from this x and this nay first and second, and we'll add it to this our new x. Here the new x will be the calculate the next iterative cell. So once we calculate it, we'll check if it's in the bound. If it's in the bound and the cell is not visited, if we starting from this true, and if it is currently false, and we can go here because it's false, and also we can check what is the content. If it's 0, then yeah, we'll visit this and we'll increment the length. Length should be 1 plus 1 because the initial length is 1 there. So that way we'll just keep pushing the new indexes and the length plus 1 in the queue, and we mark the visited new to the true. And in by doing so, if we find the uh, length, if we come to this last right bottom cell, we can directly return the length plus 1 from there. And once we don't have any cell to enter in the queue, and we come out of the while loop, and we'll just directly return minus 1 because we did not return anything, and we are unable to reach the plane. So main thing we need to keep in mind is like the calculate of the next index, and it should be on the grid boundary. It should not be out of bound, and it should be the new x and y should be equal to 0, and the visited should be false. In that way we can solve this. So I have added and checked. So again I will just run it once. If you any doubt with the code and the explanation, you can comment down, and I can explain you. And for now we can see all the test cases are passing. I just submit it and see. Yeah, so we can see that it's got accepted. Thank you, and thank you so much for watching this video. Bye.